Okay, friends, so now we're going to be talking about factoring trinomials and then binomials, okay? Tris and bis, okay? So, actually, as a brief overview, I'm going to list everything we're going to do, loosely speaking, in order, okay? So you guys can kind of hop around. Okay, so things we'll be covering in this lecture in this order is factoring trinomials, AC method, perfect squares, substitution asterisk, okay? They're going to tell you to do the guess and check method. Don't do that. It's low-key a waste of time. You can't totally, right? Like if you're in a pinch, just FAFO, right? For the factoring binomials, we'll cover difference of squares, as well as grouping, how that plays into grouping, and sum and difference of cubes, asterisk. It's a little funkier, so ooh. Okay, so here we go. Okay, first we're going to cover the AC method. Okay, so the standard form of a trinomial, typically a quadratic, let's be so for real here, it's not always, but usually is you have ax squared plus bx plus c. Of course, we're assuming a does not equal 0. Okay, so step 1. You want to multiply a times c. That's a c. 2, you want to find a pair of numbers that multiply, or find a pair of numbers that 1, multiply to equal a times c. So if a times c is 6, whatever pair of numbers you choose better multiply to 6, so forth. And 2, add up to b. Pretty straightforward, right? So, as an example, I'll run it on the side. I'll say, I don't know, 3x squared plus 5x plus 2. Okay, well, first we know that a times c is equal to 6. So we want factors of 6. And we know that b is equal to 5. So we want factors of 6 that add up to 5. Okay, what are the factors of 6? It's either, well, the original that we had here is 3 and 2, or you have 1 and 6. Okay, since this is positive 6, we want positive factors. So positive 3, positive 2, positive 1, positive 6. Because negatives, we'll get there, right? Okay, we want positive factors that add up to 5. 1 plus 6 is not 5, but 3 plus 2 is. So, the next thing you're going to do is you're going to say split b into those two factors. Step 1, step 2. Okay, we want to split b into those two factors. So now you're going to write 3x squared plus 3x plus 2x plus 2. Do you notice how the b has been split, like additively? Okay. Once you hit here, you're going to factor by grouping. You know how to factor by grouping. Once you get here, it's going to look like, oh, this and this both have 3x in common. So I'm going to write that as 3x, x plus 1, right? Plus, oh, these both have 2 in common. 2, if you factor the 2 out, you're left with x plus 1. Oh, we get to factor out a binomial. Isn't that exciting? And then you just bring it home. 3x plus 2, x plus 1. If you feel more comfortable writing the x plus 1 on this side, that's fine too. Okay? And that's it. Step 5, profit. And this is where your distribution skills are really important, okay? This is called the perfect square method. You can't always use it, but when you can, it speeds up your work so fast. Okay, let's take a pause. What is a perfect square? Well, when we talk about integers, about numbers, right? A perfect square is a number that is the product of two of the same number. So like 9 is a product of 3 and 3. 16 is 4 and 4. 25 is 5 and 5, so forth, right? And so a perfect square is something that can be written as a plus b squared, where a and b can be numbers, they can be two variables, it can be a combination of numbers and variables. Point is, they are a binomial, right? Well, if you were to do this out, if you were to FOIL this, what do you get? You have a plus b times a plus b, right? If you can't do this quickly, okay, I want you to get really good at doing it quickly, okay? You see a plus b squared, you should be able to say this is going to be a squared plus 2ab plus b squared, okay? If you have to FOIL it out a couple times, you want to distribute it a couple times for practice, that's fine, but I need you to get super, super comfortable. Do not ever tell me that this is equal to a squared plus b squared. Bad. Okay? So, that's your option number 1. What's your option number 2? Option number 2 is you're looking at a minus b squared. And I'm going to have you guys do it out really quick. Hit pause, come back, and if you're back, you should have a squared minus 2ab plus b squared. Okay? Okay. Perfect squares. They're really nice. Do you know why they're really nice? Because, hear me out, if you see something that looks like a perfect square, you could just bring it back to its factored form, like that. Okay? Let's do an example. Let's do an easy one and a hard one. X squared plus 6x plus 9. 6x is the same as saying 2 times 3x, right? Or 2 times 3 times x. Starting to look like a perfect square. Because, oh, you have that a squared, you have an a squared, your a should be x. You have a 2, you have a 2. You have your a hanging out, you have your a hanging out. You have your b hanging out, you have your b hanging out. You have your b squared, and you have your b squared. You see where this is going. Because this guy can be written as x times x plus 2 times 3 times x plus 3 times 3. Looking mighty like that first guy, huh? Because it is. All right. Okay, in that case, we can actually just write this as x plus 3 squared. I want you to be able to see these things and do them in your sleep. If I give you ready? If I give you x to the 4th minus 30, let's not do that, minus 8x squared plus 16. I want you to look at this and say, hey, wait a minute now. Wait a minute. This is looking like minus 2 times 4 times x squared. Oh, look, we already have that too. We already have this x squared. X squared squared is x to the 4th. And, oh, look, this 16 is just 4 squared. This is x squared plus 4, the whole thing squared. Okay? So, get stupid, silly, comfortable with this, then all your problems will go, most of your problems will go away. All right? Okay, as promised, okay, if you confuse easily, zone me out. Okay? If you're feeling like challenging yourself, and this is actually a really nice method, especially if you plan on taking pre-calc and calc, zone in. I'm gonna teach you guys how to do substitution. It's exactly how it sounds. We go back to that piece we were just looking at. X to the fourth minus 16x squared. Nope, sorry. X to the fourth minus 8x squared plus 16, right? X to the fourth looks bad. I don't want to do that. And that's okay. That's okay. And the reason that's okay is because I'm going to say let u equal x squared to match this, the smaller one. Okay. All of a sudden, you have, oh, well, x to the fourth is x squared times x squared, right? Which means you can write x to the fourth in terms of u as u squared minus 8, x squared is equal to u plus 16. All of a sudden, this is just a normal perfect square, right? This is just u minus 4 squared. Ah, but wait, you don't want things in terms of u. You want things in terms of x. Sorry, you want things in terms of x. Just unsubstitute. X squared. Just kidding. You don't want things in terms of u, you want things in terms of x. Oh ho ho. This now is suddenly just x squared minus 4, the whole thing squared. Ain't it magical? I think it is, personally. Okay? Okay. Factoring binomials by difference. That is the prettiest. Anyway. Squares. Okay. So, earlier we had a plus b squared, which is a squared plus 2ab plus b squared. You have a minus b squared, which is a squared minus 2ab plus b squared, yeah? Now I raise you a plus b, a minus b. Go ahead, fill this out real fast for me. Okay, if you're back, it's go time. This should give you a squared minus b squared. Where'd your other two terms go? So glad you asked. If you FOILed it, you would know it's a squared plus ab minus ba minus b squared, which is the same as saying a squared plus ab minus b squared. These two are the same. ab minus ab is 0ab, a squared minus b squared. Once you start recognizing these patterns, sometimes substitution helps. You can't unsee it. Okay, now, how are we going to use this in grouping? I'm so glad you asked. Let's do an example. So you have a cubed plus 5a squared minus 9a minus 45. Okay, hear me out. If we split it in half like this, right, this half is going to give us a squared. And again, if you can't keep up with the speed, that is okay. Pause this, slow down, do it the long way, do it at your own pace, okay? But if you're keeping up just fine, carry on. This will give you a squared. You take a squared out of here, you get a to the first. Take a squared out of here, you get 5. Okay. Minus, no, not minus. And then, I'm going to keep this group separate. I'm going to say plus and then negative 9a minus 45. How are we going to make this look like this? I'm so glad you asked because, well, let's start here. I could pull out a negative 9, right? I could totally pull out a negative 9. Negative 9, and then what does that leave you with? Positive a, negative 9 out of here gives you with 1 positive 5. Okay, we're going to rewrite this bad boy as a squared parentheses a plus 5 plus negative 9, a plus 5. Okay, both guys have an a plus 5. Let's pop this bad boy out. And I'm gonna put in some equal signs. Please put in some equal signs, friends. Okay, I'm gonna pull an a plus 5 out here. You're gonna open parentheses. Well, when you take an a plus 5 here, you're left with an a squared. A squared. When you pop out the a plus 5 over here, you're left with minus 9. Or plus negative 9, then you combine the negative sign down. Whatever, I don't really care. Alright. And you're going to be like, oh, but Amanda, where does the difference of square? Do you see this? Do you see this? You can write this as a plus 5, right? And this guy is secretly just a plus 3, a minus 3. oh, but it's all being multiplied. You see how this is being multiplied to this, right? There's no addition here, and this is being multiplied to this. Oh, and then you can just call that a plus 5, a plus 3, a minus 3. Ta-da! When you're factoring by grouping, sometimes you'll find that you can factor things further. Do it! Okay, last thing. This is going to be the sum and difference of cubes. It's going to be a doozy. Could you do this manually? Yeah. What you would do is you would add some things and then subtract some things and then do some factoring by grouping and then whatever's. This is one of the few things I will kindly ask you guys to memorize because it's just so much more efficient. Okay? So the sum of cubes, which can be written as a cubed plus b cubed is equal to a plus b times a squared minus ab, not 2ab, just 1ab, plus b squared, okay? And for difference, which is a cube minus a cube, right? A cubed minus b cubed. This is going to be a minus b. Do you notice how these two signs match? And these two match? Yeah, that's what you want. And the inside is going to be a squared plus ab plus b squared, okay? So, a quick memorize, I suppose, is plus, plus, minus, right? This is going to be minus, minus, plus. The monomial matches the term. The monomial matches the sign. The trinomial does not. Okay? Okay. Okay, so for grade scope purposes, for trinomials factoring, page 102, numbers, just read it. Just read what I wrote down here. Oops, read what I wrote down here, okay? This you don't have to submit to grade scope. For binomials, page 104, these problems, and if you want extra practice, just kind of mixed problems, page 105 is called problem recognition exercises. Okay, this is what they look like. Yeah. If you're not feeling confident with factoring, which I know a lot of you guys aren't, do it. Just straight up do it. Make your dreams come true. Become so disgustingly good at factoring. Okay? This video is already like 20 minutes long, and that's way too long for my taste. Okay, bye.